Hello? Hi, hi. Sorry, I'm like late. Oh, the classic autoclave immediately. Thank you, thank you. I'll be back in 10 seconds. Hello. Thank you. I appreciate the autoclave considering, I'll be on vacation after this. Hello, Gran, and thank you for checking in, Curlotus, and thanks for checking in, Ripco. And thank you for checking in, B. Hello. This is going to be a relatively short stream. I had another paper planned. Oh, good luck stream. Thank you, Caldonia. Thank you. I had a different paper planned to read, but I realized it was a bit long and I still have quite a bit to do. So I figured we can do a different paper. And this isn't even a paper. I mean, there's papers they reference, but this is a NCI, the National Cancer Institute's kind of like summary of some papers. So, I'll even post this in the chat if anyone wants to read it. Like read along, not on like themselves, and also click the papers themselves. I will not show the papers on stream. I do have access to them. I don't know if it's hard for me to tell if I'm like if they're paywalled or not because I click and I see my access immediately. Oh, thank you for checking in, Gren. Hello. Uh, I this isn't a super recent paper or even like science. I mean, it's December 2024. It's still relatively. Yeah, you did. You can redeem it yourself, Gren. But yes, I believe you did miss it. Oh well, you better save up then. But yes, you did in fact miss. But there. Oh, don't worry, Ripco's got you. And I'm back. Okay. And I've been autoclaved twice now, twice in one stream, in just this short amount of time. I know you guys are gonna miss doing that. You guys are gonna miss autoclaving me. I'm gonna multiply so much while I'm on vacation. Sadly, the stubborn little bacteria always lives. Yeah. You guys can't get me, but I appreciate you trying. I appreciate the effort. Maybe one of these days you will get me. Maybe I have to autoclave you a lot when you come back. Yeah. You can mass chain the autoclaves. Autoclave after autoclave after autoclave after autoclave after autoclave after autoclave. It's always going to be a battle against you guys. One of them's open, the other looks closed. Okay. I will. Either way, I think we won't need to go too deep into the papers. This article, unfortunately I can't stay around too long. That's why we chose a nice little NCI summary article that has the good science described in a good way. I like these kind of articles better than what is it like uh the pop sciencey like website articles, cuz sometimes I feel like they over exaggerate the results really highly, and then they make their way into on Reddit and like at r/science, and they have like the weirdest conclusion as the title, and I'm like, I don't think that's what the author meant as the conclusion. Whoa. Okay, buddy. Uh okay. You got a lurk and you're gonna get ready for work? Okay. I hope you have a good time at work. Hope it's not too many hours today. Okay. So, as I mentioned, I saw this article. I saw the scientists who were working on. I can't remember which paper it was, but I saw this presented at one of the conferences I was at recently, and I thought it was really cool because as I've talked about, I do a lot of cancer-based science in my day-to-day life, and I'm a bacteria, and so mixing the bacteria and the cancer is always very interesting to see. And I also think it's something that might be a little bit surprising for people that don't know too much about cancer research. They might be wondering how bacteria even play a role in cancer and immunology. And even this method that they talked about, which is E. coli just straight up shrinking tumors, is pretty profound. A lot of the research we've seen with bacteria and cancer, it's a lot of detection based kind of cancer research where it's bacteria in the body tend to give off certain signals, and that can help us detect if this person has cancer or not. And so that's kind of been the thing we typically see. So, but this was really cool. So I'm gonna just go ahead and read that. Just read the article, and we'll just start going through that. In a pair of NCI-funded studies, also NCI is National Cancer Institute. Very sad, that it's something that has been losing a lot of funding as of late. But we still appreciate that's why we have to appreciate all the research that they're currently doing. Okay, sorry. I'm making sure that you can actually see what's going on. Researchers have used an unconventional tool to successfully shrink tumors in mice, the bacterium E. coli. And if you don't know what E. coli is is one of the most prolific. It's the bacteria. It's the bacteria. If you don't know who Mr. E. coli is now, we gotta get you. We gotta get you up to date. Yeah, it's the one we use in science. It's the science. It's one of the golden standards of scientific research. Also, it's just the one we probably hear the most about. I feel like E. coli, people likely know the word E. coli and don't know what it actually stands for. Okay. In one of the studies, the researchers used the bacteria to teach immune cells how to find and attack cancer. The other, they use it to deliver a protein that enhances a commonly used immunotherapy. So immunotherapies are typically some of the more common ways of treating cancer. E. coli is easy to grow, very well inserted. It's incredibly characterized. Everything we would know, everything about that little guy, we kind of know about it. And so that makes it really easy to manipulate it for what we want to do. And so, yes, immunotherapies are just a common way to treat cancers. There's lots of different forms of cancer treatments. So things can be you've heard probably chemotherapies and immunotherapies. There's antibody drug conjugates. There's just so many. They all work in different ways. It all depends on what kind of cancer it is and how we're trying to target it. It gets really complicated. Cancer research is one of the most complicated things, but I don't think that's really surprising to anybody. And oh my gosh, speaking of how complicated cancer research is, this is a tangent. I always get nothing gets me angrier than seeing people comment "Oh, these companies, they know how to treat cancer, but they know how to cure cancer. They just don't want to do it because they're making so much money." And I'm like, oh my gosh, are you insane? Are you insane? Do you know anything about cancer research? Do you think they're just like farming infinite money? Like, they are getting, I'm not gonna deny that they're not getting infinite money from these therapeutics, but do you think like they're hiding this magical cure or something? Oh my, and nothing like sets me off more than seeing those in the comments of like anything that has to do with cancer research that makes its way to like the public area. Cancer is insane and hard to deal with. Yep. Oh, hello, Dr. Echolas. Finally managed to appear in one of your streams. As everything in biology is 1,000 times more complex. Exactly. Yeah, it's sorry, my streams, it's always I think I've gotten that a lot of times. I tend to cancel a lot. It's mostly because I have a lot of things to do with work. Hello, Zanami. Hello. So, moving on out of the cancer, the immunotherapy treatments. So, let's continue on here. Unlike the strain of E. coli that causes food poisoning, the one that researchers worked with, called E. coli Nissel 1917, doesn't cause illness. So this is kind of what this is another part I think sometimes gets confuses people that aren't familiar with bacteria research. I've always seen people go, "Oh, don't you get sick if you use that bacteria?" And it's like, well, you have to be careful, but for the most part, these things are they're not going to do much harm to you. In fact, you're probably going to do more harm to them if you're not careful. You're going to mess up your experiment. If you're not sterile, you're just going to mess up the experiment more likely than you getting hurt. But that also, it's different levels of biosafety. In fact, it has been used as a probiotic for more than a century, explained Nicholas Arpaia, PhD and immunologist at Columbia University and lead researcher of the new studies. In the first study, the researchers engineered E. coli to deliver small bits of tumor proteins to immune cells. Like giving a search and rescue dog an old T-shirt or a missing person, the bacteria show the immune cells what the tumor looks like so they can find and attack it. Okay, this is why I like the NCI papers, because I feel like it's a great explanation of like I can't explain that kind of method of finding of immunization even better than that. Yeah, there's lots of these microbe things that are like, hey, so there's 3 of these that are bad, but there's 5,000, so we know about, and maybe 10 times more total. Yeah. I think there's the bad bacteria we know, people know about or aware about. They are incredibly bad. So then everything kind of gets this bad rep. But, like, the most of them are kind of not doing anything too crazy, but you know, the bad apples will always have more notoriety and make everyone look bad. That's why I get autoclaved. I'm getting autoclaved and harassed as a bacteria because of the bad guys. I got tired of explaining that the coronavirus we vaccinated Nick their dog for is not COVID-19. Oh my gosh. Yeah, it's really rough. I am such a big fan of scientific communication and trying to communicate the sciences with people who are not like well versed in sciences. I think it's very fun, and it also makes you think pretty critically beyond what you normally would think about science. It's just using a different part of your brain, because it's really easy, in my opinion, to explain science to other scientists. I mean, when I would do, like lab meetings and scientific meetings, I think that was not too bad. I mean, it was scary. It was kind of like, oh my gosh, I'm about to be judged and criticized for everything that I've done this last month. But that's like a different part of like the science explanation. That's just me being fearful and anxious of my lab. But the science explanation part, it's really like straightforward when you don't have to explain background knowledge, and you don't have to you assume like a lot of these jargon and terms are just common knowledge, but they're not. They're really not. Judge, yes. Criticize, no. You did a great job. Oh, thank you. It's always just, it's always like, it can be, just a different level of anxiety when you're talking to other scientists. But talking to non-scientists can be hard can be very hard. You don't want to, what I found is it's hard not to feel like you're not being like patronizing. Like, you don't ever want to come off like, oh, I'm this amazing, wonderful, knowledgeable, highly educated scientist, and I'm here to spread like my great knowledge and amazement to you peasants. You never want to do that. And I saw so many scientists really do that during the pandemic. And then, understandably so, people got quite upset at scientists. Not that they should ever be upset at scientists, it's just it was a very, very emotionally charged time. And it sucked. It sucked all around. Yeah, completely agree. Saying something to non-scientists is hard. Yeah, it's incredibly hard. Talking to non-scientists, less hard, more difficult to sound like a person. Yeah, it's just a challenge, and we as scientists don't get that kind of training very readily. As I went through my PhD, I had to get those. I wanted those opportunities to train my scientific communication skills. I kind of had to go out of my way for that. Like, I had to sign up for things like, oh, I want to teach high schoolers. Oh, I want to go talk to people. Oh, I'm autoclave. Thank you, Gren. And I need to just do that myself. And I'm back. Hello, I'm alive again. And you have to go out of your way. But I really think almost all scientists should be like, that should just be kind of a standard on your journey. Because if you can't explain what you're doing to just a normal person who might have zero background, I think it's really hard to convince people to give you money. I think mostly because you don't know how much of a scientific education the people have. Yeah, the scientific education is incredibly, it can vary so widely. Some people have very little, and then some people are basic knowledge. It's been helpful for your life, though. Yeah, it's been really helpful. I mean, I've been pursuing it because I knew that this was something I was really motivated by. I've been autoclave 30, it's because I've been autoclave 32 total times. Yeah, total, it's not unique to you. Yeah, it's 32 total times. I think most of those, however, were me testing it. We need to get the autoclave check. You're still alive. The autoclave, you know, like how it is in like your university institution, like you would go and you'd see that the autoclave's broken on this floor. I think the autoclave is broken on this floor, but you guys are still using it and putting me in it. We have to call the maintenance person, but they haven't been picking up their phone. Maybe one day the autoclave will be fixed and you guys will autoclave me for the last time and I'll be gone. I get that, but I thought you weren't autoclaved that much before. I think I would say probably it's that number is way bigger than it is. I think it's like 20 of those times were me as I was testing how the command goes, because I didn't know how to make it so my model moves and then how it moves me back. Oh god, the worst graduation on the internet. Chat kills the streamer, yeah, and I'm gone. I'll have like the smiling face anime girl, like, you know, just like picture like and then I'm gone. You've autoclaved me. I'm dead. Okay, we got super distracted. Treating mice with the bacteria educated immune cells and shrank tumors or eliminate them completely. Okay, to talk about this study that they did, it's important to note it's not like the E. coli are going out there. They're not going out there and killing the tumors. I think that one can get misconstrued in this way. This one's public. Okay, so if I click on this. Okay, oh, it is public. Okay, it's cut off on the stream though. We won't need to click it, but if anyone would like to read that more, definitely click on that. Definitely click on it and learn more. These papers, if you do not have a science background, they are quite dense. I will warn you for people who have not who don't have that same level. Like nature papers do not play around with the academic jargon and prior background knowledge like required to read them, which sucks. I do hate that. But the nice thing is we have articles like this NCI one to kind of break down all of that work into about a paragraph. So basically, same with paleontology papers. Yeah, science academia papers are just terrible. Absolutely terrible. I feel like I've read like math papers, like math and physics papers, and I go, oh my gosh, how does anyone read that? And then I realize that is how people see the papers I'm reading. They probably go, what the hell is this? And same, I'd be happy to help anyone in the Discord too. Oh yeah, I'm also like, if anyone, goes out like beyond this paper. If anyone ever has like papers they would like to share or they found difficult to understand, just please post it on the Discord and we'd all, like, I think me and my community, we'd all just be happy to talk about it and read through it and see what we can discuss and figure out. We're all science nerds over there, of different backgrounds too, which I think makes it more interesting. That way, everyone has different perspectives, and some people might not even be biological sciences, and they still have their own interesting perspective they might be able to put out there. Do we have any periodicators more than regular folk? I don't think I know any like that. I can't think of any either. The best you can get are like websites, like news websites that summarize articles in very simple ways. But the problem is I'm not a fan of most of them. Like a lot of them, I feel like they oversimplify, which it's hard though, so I can't blame them. Like for example, if you go to the r/science subreddit, I think a lot of times they will link newspapers that are referencing a paper, and it gives you the gist, but I think sometimes things are lost in the conversion of making it simple. And so things like sometimes a big thing that's like not mentioned is like the methods. Methods can be really big, especially when they're talking about something that's maybe population based. And so something that sounds really crazy might not end up being as crazy because the methods part is just kind of lost in like it's just not mentioned at all. So you don't really know what the sample size is, and you don't know what kind of like selection criteria they used, and you might run away with just talking about the article. If anyone has any paleontology papers, they're not understanding. Yeah. See, everyone is very kind and helpful, and they want to share their knowledge. I find NPR does a decent job of giving you information. Yeah, I like NPR too. I'm also not a fan of the oversimplification, but it's kind of hard not to as well. I mean, that seems pretty reasonable. You either get technically or full and simple and missing info. That feels like the scale. Yeah, it's just impossible. I don't really know how you could ever simplify it without missing something. I try my best to simplify it. Like for example, this summary of the first study here, the research, like how they use E. coli to train immune cells. This is I have not read the paper in full, but it's probably a good enough simplification of what's happening in that study. And maybe, and in this case, the details that are lost in this simplification probably will not mean too much to most people. Like, I think just knowing that there's research to say you can train immune cells with bacteria to help treat tumors in mice. Let's make sure we know that it's in mice. This has not been done in humans. In mice, I think that's a good enough like summary for a person to go away with, run away with. I had to teach myself to understand paleontology papers, basically. Yeah, I think I got a lot of training in undergrad to understand papers. Like I feel like it's not like they don't outright teach you, but they're kind of like teaching you as you know you have to do homework, and it's based on a paper or it's like whatever. It's not like the assignment was understand how to read papers. I guess the third way is using time simple and missing technical and full by someone who knows what they're talking about for an hour. Yeah. NPR Science Fridays might go. I do love NPR Science Fridays. I do wish scientific journals didn't use unnecessarily hard to understand words. Yeah. This was something my undergrad research advisor, she really drilled it into us that we should try to avoid unnecessarily complicated words when possible. Because it doesn't really add anything to your paper. And we should also try to make, even if the information might be hard to understand, you should try to do your best to simplify the delivery of that information, if you know what I mean. Like, the words shouldn't be too complicated for no reason. And also the structure of the sentences themselves should not be too hard to understand. You should try to make the sentences very straightforward. Like, there's no need. Sometimes academic journals, it's so bad how the sentence structures are put together. They, like, are just purposely obtuse or poorly written. I'll just say it. Sometimes they're just poorly written. But I think it's because there's this, I don't know, not like this feeling that academic papers are supposed to be constructed a certain way. Like the academic language is supposed to be this overly just overly obtuse, hard to understand sentences. But that shouldn't be the case. I think the information can be difficult, but you should try to make it as easy as you can to try to get to the information. Of course, it's really hard to do that. I try to be, when I write papers for academic submission and journals, the editors do their best to go, oh, we should make it sound like this. And I have to stand on business. And say, no, in fact, I don't think we should write it like this. I think it's actually harder to understand when you write it like that. And it's hard. It's like when you are not a super senior scientist either, it's really hard to have that discussion with the editors. But I try my best to get those papers will be easy to understand in one way or another. I've also mostly nowadays, I don't do wet bench research, so I don't have actual data. Like my own data collection, I'm not writing about that. I'm typically writing reviews and kind of like data collection of other people's data. And so I always want to make sure like I am making that information easy to understand too. It often ends up being, we're trying to give info to scientists. It does end up being that. It's just like, we're trying to give this info to these super niche scientists in this field. And so it's a hard thing to fix. And maybe people would argue there's no need to even fix what isn't broke. Okay, that was a lot of tangents. Sorry, I get really passionate. About academic papers and academia and writing and stuff. Okay, so the first study was about training training immune cells with E. coli. And let's look at what the second study. In the second study, the researchers engineered E. coli to deliver a protein to tumors called interferon gamma, which is critical for immunotherapies to work. In mice, combining an immunotherapy drug with the engineered bacteria kept the tumor growth in check longer than either treatment on its own. Okay, so this is like a completely different method. So we're not exactly training immune cells anymore, but we are using the bacteria still. And so interferon gamma, if you have never taken an immunology class, it is a cytokine, and it has a really big role in the immune system for like host defenses against infections. It's, produced primarily by T lymphocytes, natural killer cells, and antigen presenting cells. And then I say all these words, and like those are also too complicated for someone who might not even know what biology is. So, just know that it's a good guy. It's a defense. However, it's a good guy, but in too many doses, it can do bad things. You never want too much. You never want too many of these things, Immunology and immune cells, it's all about like a balance. Too much, and now you've got damage and inflammation at the site of whatever infection there is. We love tangents. This feels like in high school when some students try to get the teacher to go on tangents to distract them from making us do actual work, except everyone just has ADHD or short attention spans. Yeah, I'm such a tangent goer. I'm not going to say I'm bad at it. I'm great at tangents, and there's no reason for me to be sorry about going on tangents, because that's just how my brain works. I'm just making the connections as I'm talking. The cells that attack bad things, there's a bunch of them, and they wield a bunch of chemicals as weapons. Amazing definitions there. That is exactly how it goes. The chemical weapons, they're good to help, stop infections. However, can't have too many things getting blasted, You don't want to go pew, pew, pew all over the body. Pew, pew, pew all over the body, not good. Not good. Uncontrolled pew, pew, pew all over the body, not good. So they were able to engineer these E. coli because of the fact how much we know about E. coli. E. coli is just that standard bacteria. And so if we wanted to deliver interferon gamma, we know exactly how we can like make that bacteria do that. That's why this is like such an amazing vehicle of a bacteria for all these kinds of research. That's how you end up with autoimmune. The weapons start doing friendly fire if there's too many of them. Yeah. Autoimmune, now all of a sudden you're just fighting yourself. There's not even an enemy. You're just going pew, 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 all over, like, everywhere. I do the same thing with tangents. Yeah, I think it's hard not to be. I don't know how people can stay on topic. I feel like you have to force yourself to do it. So these were published in Nature and Science Immunology, respectively. If you don't know, like, science journals, these are the big boys of the science world. They are what you call like kind of like the gold standard of science research. If you can publish in these, that means you're doing really well. That means you've got some good research going on there. I've published in Nature once. Not for research, but it was like for a review. So it's not exactly Nature. It was like an offshoot of Nature, but it says Nature on it, so that's good enough for me. I'll say I published in Nature, asterisk. These are early proof of concept studies that will warrant future follow-up in human studies. Some of the research has come out on the now completed Immuno-Oncology Translational Network, which is part of the Cancer Moonshoot. So the Cancer Moonshoot is that the government initiative to basically end all cancer for life. You see a lot of these kind of initiatives, and I feel like you see a lot of pessimism toward them. Basically, people going, and they already know how to treat cancer. This is just like a money laundering scheme. I won't go back on that tangent because I went on that tangent literally at the start of the stream. But these are important initiatives. It counts. Okay, it counts. I'll take it if it counts. Let me scroll down. Using bacteria to make cancer therapies. Certain types of bacteria have a penchant for growing in the crowded, harsh conditions inside tumors. So yeah, a tumor, the environment of a tumor, it's very, very different than like a normal cell. There's a lot going on in there, which I mean, is it that surprising that there's a lot going on in there for something that's killing you or can be killing you? And because bacteria naturally grab the attention of immune cells, they can help trigger an immune response against cancer. Plus, it's relatively easy for scientists to alter bacterial genes, including making multiple genetic changes. The cool part is with bacteria, you have a very large capacity to deliver many types of therapeutics, said Tal Danino, PhD, a biomedical engineer at Columbia University and lead researcher of the new studies. Together, these characteristics make bacteria an attractive choice for delivering cancer therapies directly to tumors, he said. Indeed, scientists are currently testing many kinds of bacteria-based cancer therapies in clinical studies. I kind of like, when I read this, like all these studies, I was so sad because I feel like this would have been something I really would have loved to research as a grad student. But alas, I did not like cross paths with any scientist that did this. I think I was probably at the wrong university if I ever like to do that kind of research, which is always sad. It sucks when you go to I'll say like a relatively small university for grad school, and then your options are a bit limited for what kind of research there is. The bacteria, like microbiology related department of my school for my PhD was pretty small, so the moment I got told no by a few of them, it was already over for me. So if you're ever considering going to grad school for biomedical sciences, I would be very cautious about thinking about how like the faculty and like your backups and the backups and the just backups. Because you just never know. I was not that prepared, and then I made many critical errors because of that. Doctors Danino and Arpaia have previously designed several E. coli-based cancer therapies, including one that delivers modified versions of 2 immunotherapy drugs. Now they wanted to see if E. coli could be used to deliver other kinds of immunotherapy. Interesting. Engineered E. coli as a cancer treatment vaccine. Cancer treatment vaccines, that's a topic I also want to do a stream about. Not now, but in another time. I'm trying to rush through this a bit because I was like, oh, we went on too many tangents. And I need to end in like 15. Engineered E. coli is a cancer treatment vaccine. For the first time, the researchers' goal was to make a cancer treatment vaccine, a treatment that teaches the immune system to find and attack cancer. Cancer vaccines are such insane research. Every time I've gone to a poster that does cancer treatment vaccine research, I go, wow, you guys are doing some crazy things that I have no idea how to even get started on this. They engineered E. coli to make pieces of 19 abnormal proteins, also called neoantigens, that are found only in mouse colorectal cancer cells. Teaching immune cells to see these specific neoantigens not only helps them recognize tumors, but also lowers the chances that immune cells will inadvertently damage healthy cells, the researchers explain. Again, this is all about manipulating and using that bacteria to try to find tumors. Oh, goodbye, Gren. Bye. Have a good night. See ya. I'll see you at end of July after my vacation. Bye bye. In mice, they also made several changes to bacteria that greatly boosted its capacity to make the tumor proteins and present them to different kinds of tumor cells. Take natural thing the body does, use it for good. Yeah, exactly. A lot of this research is really like thinking like what is cancer, like what are tumors avoiding? The tumors are able to avoid our immune system. So how do we like bridge that gap? How do we make it so they can't keep avoiding? How do we like get the immune with the finding and fighting the tumors? In the mice with the same colorectal cancer used to identify the neoantigens, a single injection of the engineered bacteria greatly shrank tumors or eliminated them completely. Complete elimination is so interesting. That's very impressive. A lot of times of these, I've read enough clinical, like preclinical research of cancer therapeutics. A lot of times you do not get complete tumor like elimination. You get a hefty amount of tumor shrinking. Typically they'll be like, oh, 40 to 60% tumor shrink, and that's usually pretty impressive. Lots of bio stuff ends up being, we don't know how this works exactly, but we can hijack it for what we want. Exactly. It's all about going like, what can we do here, even if we don't know? It can sometimes feel like a bit of a black box in that way. Various kinds of cancer-fighting immune cells were activated in and around tumors treated with the engineered bacteria. The treatment also tamped down the activity of immune cells that help tumors grow. And the researchers it said the approach can be adapted for other types of cancers. For example, the team also engineered bacteria to make tumor proteins from melanoma cells. Treating mice with those bacteria shrank melanoma tumors. As you can see, it says they only shrank it. So it doesn't sound like this would be as effective as it was in colorectal cancer. And that's kind of the reality of it. It's very difficult to make something that's pan-cancer, you know? There's so many little little bits and pieces that are different for cancer type to cancer type to cancer type. But shrinking is still very good. Don't get me wrong. In each of the experiments, mice treated with engineered bacteria didn't lose weight, suggesting that the treatment didn't cause any major side effects. That's also another thing. This is something I don't keep in mind enough. That's probably because I am not the clinician or pathologist treating patients. I'm trying better to like think about this though. It's about how to what ends are these treatments, to what ends should we use these treatments if they're hurting the patients? Because some treatments, they can have incredibly major side effects. And I'm sure people have heard about that with like chemotherapy. Chemotherapy is super well known at this point to cause so much pain to the patient. It's causing like them to throw up and be nauseous and sick, and it's very painful, and patients don't want to go through it, and it's stressful. And all that's not good also for the end goal of treating a human, which is important to keep in mind. You can't have a happy, healthy patient if they're suffering every week because they need to get this IV injection for 3 hours that gets infused and they're nauseous and losing a ton of weight. Happy to be able to show up, but I'm inside. Oh, hi, Frost. And no, it's okay that you're outside. I hope you're having a fun time touching grass outside. And one of the worst parts of cancer is it's kind of still you, so you have lots of ways for it to end up. Yeah, it's really sad. It's one of the worst things ever. It's basically poison. You can still be slowly dying as the tumor is being treated, which is terrible and awful. I am very chemotherapy. Yes, it's literally poisoning yourself. That is why a lot of cancers are trying to move away from just pure chemotherapy, but it's still really difficult. It's not that easy. Oh, thank you for checking in, Weetabix. We just don't have that kind of those kind of selective therapeutics for every case. Individualized medicine is like a huge thing people want to move towards, but it just takes a long time. A long time to figure out what's going on in all these specific cancer types, and also how do we even target things. Sometimes we know that certain cancers express certain like signatures, but we can't do anything about it. So nice to have a celebrity on stream. Love the username. Cancer is so complicated because every type of cell is its own type of cancer. Depending on what type exactly breaks in those cells, there can even be multiple types of cancer. That's also it's the complexity of tumor research is crazy. I don't even do the research. I'm just someone that takes what's being written and writes about it, and I like lose my mind sometimes going like the heterogeneity of tumors is like crazy. Like I don't know how you're supposed to really understand what's going on when there's so many different parts of this tumor. It makes it really complicated for me. It makes it really complicated for me when we're trying to write about something, and then we have a paper that shows some kind of therapeutic implication, aka like how it's working with a specific type of tumor, but the tumor is like highly specific to this patient because there's such different mixes of it. And then it's like, well, I don't know if this is like a common case. Yeah. Oh, yes. Thank you. Sorry. It's another one of those. I jargoned all over the place over there. I'm sorry. It's one of those times where it's like, I feel like everyone knows that word, but they don't. And that's okay if you don't know that word. That is okay. But it's my fault for forgetting. Given these promising results, the researchers are interested in moving the treatment to human studies. This is where the big magic is, and this is where things can fall apart real fast. I was trying to think of the percentage off the top of my head, but I don't think I know an updated percent. But many studies will have promising results when you treat mice with tumors, and then the moment you go into a human study, it's just not like the power of that treatment is just not there, and sometimes we don't really understand why it's not there. Sometimes you can have let me asterisk. Sometimes we don't know why it's there. Maybe the authors sometimes might know why it's there because they might have done some tomfoolery in their preclinical results, and you can't exactly fudge the human numbers as easily when there's real life patients. That's not always the case, but it does happen, so asterisk. Fortunately, humans and mice are different. It can be as simple and complicated as that. Yeah, that's usually the case here. It's just mice immunology and biology is just way more simple than human immunology and biology. And we also study mice. And they have this amazing background for research that helps with replication and like seeing the same results over and over. But humans just aren't like that. We are so different. I will be different compared to you. And even though like we are maybe both humans, I am human ? Trust me, I'm human. And it's just the fact of the matter. One like that I was amazing with in humans I didn't work was with salamander regeneration. Oh, interesting. I didn't know about that. Scientists are not always honest. Shocking, I know. Oh yes, Speaking of scientists not being honest, I desperately want to go through PubPeer one day, and that's a website where people basically anonymously call out papers for having fake results. They will post pictures of figures from a paper and go, "Hello, author of this paper, can you explain why you just flipped figure 1 for figure 2 and said that they're different data?" It's like the messiest. It's so messy, but it's really, really interesting. And that's why we almost always stick with the big periodics. Yeah. Even, unfortunately, even with the biggest journals, sometimes things can fall through the cracks, and it's sad to see. Very, very sad to see. That'll be a stream in the future for sure. There's some case like I will pick the notable ones because some of them like blow my mind to the level of detail they go to like falsify their results. It's insane. And it just goes like, as someone who was a bench scientist, I go, what? Well, you guys were faking your Western blots while I was here crying and having to redo them every week. You guys were just photoshopping. I wish I was like, I wish like, you know, it was that easy. All my troubles could have been solved with photoshopping, and you still get into a high impact paper. I mean, it doesn't work out in the long term because they always get caught and then their career is over. So it's not like I actually would not want to do that, but still. We pick animals to test on because we try to find ones that work similarly. Mice react very similarly to humans to drugs and other things, but it's not exactly the same, and we use them because they're small and breed fast. Pigs are probably better, but they take a while to grow, and humans have feelings. Yeah, pigs are definitely they're better model, but it's way harder to do the extensive kind of research you need to do for a lot of these therapeutic trials. And I think tumors grow pretty slow. In regards to cancer research, they grow slower in these bigger animals. Compared to mice, you can just inject some tumor cells, and a few days later, you got a mouse with a tumor. You're not jealous, just offended. Yeah, I'm not jealous. It's just like hello, we weren't all struggling together. You're telling me some of us are just cheating in science? Hello? It's crazy. I don't get it. How can you some of them are super poorly photoshopped too. Like you can see the literal artifacts when they moved the Western band like plots. I'm like, who did this? You didn't even try. Hi, Beppo. Hello. I hope you're having a good Friday. We can mess with pigs' genetics and then translate their organs into humans. That's how similar it can be. Yeah. I mean, yeah, there's been amazing results with that. It's very, very good. It's just, there needs to be, like, if we want to really move away from mouse models, we really need to think about, like, how we're asking people to do their research. People are doing their research. They're expecting results really fast. We need to, like, submit grants really fast, etc., etc. And so you need something that's going to give you quick results like a mouse. Western blot. Let me try to remember. Some kind of measurement of size of molecules. Oh, yeah. So a Western blot is for, it's another word for it's like a protein immunoblot. So you use it to detect the proteins in a sample. It separates the proteins by size. You use a gel electrophoresis, and then after you separate the proteins, you stick them onto this membrane, and then you're able to usually do something like wash that membrane with certain antibodies that stick to specific proteins. And then if that antibody's stuck, you can like look for fluorescence, and that can kind of confirm to you, oh, hey, that this protein is actually in my sample. At least I haven't seen much of the AI generated papers anymore. That's true. I think the AI generated paper, like, generation, it's been dying. I don't think dying, but it's at least been very quiet. I also haven't seen like any AI generated figures in a bit either. I was very pleasantly surprised when I went to a conference and there was no AI generated like figures or papers I saw of. There were a ton, and I'm gonna emphasize a ton of booths there that were just ChatGPT wrappers advertising their products for hospitals to use. It was insane how many of them were just like a literal GPT wrapper trying to like say we can emphasize your we can help your productivity with our LLMs. And I'm like, ugh. There's like so many of them, and I was like, I'm pretty sure you guys are all doing the same thing. That was like the new hotness there. Everyone wants to be a GPT wrapper. Okay. Unfortunately, we went on many tangents. I think we got the gist of what bacteria and cancer are related to, though. I want to keep streaming, but I have to get things packed up for my trip tomorrow, and I will have to be on vacation, and I will be away from you guys until 3rd week of July. I can't remember my exact return date. Let me sit in front of you guys. I love being able to talk science with you guys. I think it's fun to just yap about all the different sciencey things and talk about what's going on in research and make sure it kind of keeps me in check too of how do I communicate science with people that are not scientists, because definitely my community has quite a bit of scientists, but I know there's also a lot of people here who don't know many things about science. Number 1, bacteria sacrifice themselves so the body knows what to attack. Number 2, bacteria make chemical that helps immune system do work. Yep, exactly. I will post these papers on my Discord. Is it like a field trip? I'm just going on vacation. And you guys, my bacteria buds, you guys will be in the petri dish. I will leave you guys plenty of food, and I'll leave you guys plenty of media so you guys don't die. AKA, I'll be uploading videos. I recorded a bit of videos this week. I have to edit them, but I won't be able to stream because I don't know what the internet situation will be like at where I'm going to be vacationing. So I'll just take a break. Please, someone send over a nitrogen. I'm running low. Okay. I'll make sure the incubator is up and running, and no one's gonna die in their petri dish. I love seeing more sci VTubers around. Me too. I love science VTubers. I follow so many. I feel like sometimes I just follow science I follow VTubers that just look like scientists, even though I don't think they do any. They don't do anything science related, but I just follow them because I'm like, oh, you're science. They're not actually science, but the vibe is there at least. I'll have to focus more on science when I stream again. Oh yeah, it's up to. Honestly, I don't blame people who don't want to focus on science. Sometimes, especially if you are a person that's working, it can be a lot. It can sometimes be overwhelming to think about science at work and then go to stream and then think about science again. It can be a lot. Sometimes I have canceled my Friday streams because I just did so much science all week. Just leave me in the incubator and I'm good. Okay, I've got you. We're far apart, but we have a few. Yeah, I'm just happy. I really love the science VTuber community. I only joined it. When did I started streaming in February, and it's been a few months now, and I'm just so happy to be part of it. It's been a wonderful time so far. I will be back on July end of July. I'll just say end of July. But I'll be active on Discord, so you know, if you are not part of our Discord, I implore you to join and, you know, keep in touch with me and the community. That's where you're going to find me and updates about when I'm going to be streaming and coming back. So, you know, join. I'd be happy to. I'll be happy if you're there. I'm also I haven't been as active on Twitter lately, but you know, I'm also active on Twitter and other social media, and you can find the videos on YouTube and TikTok. Somehow, you guys, I don't get it. I don't get how my TikTok became my most followed platform, but we have like 350 followers on there. I don't really get it, but you know, I'm happy, and it seems to get people from. I think people do find me and end up coming to the stream from TikTok, so that's good to hear. Anyway, I will be back. I will miss you all greatly. I'm like dawdling. I wonder if there's anyone I can raid. I'm gonna send you guys to my friend Resta, and you know, I will see you guys then. Bye 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 bye.